So today we've started talking about something new for us, and that's our types of numbers. And we brought in some really new looking notation. So when we talk about types of numbers, well, let's start where we started as babies. So as babies, what did we first starting to count with? We started with 1, 2, 3, and then we kept going up. This set of numbers are called our counting numbers or our natural numbers. And we use the symbol n with like a double slash at the start of the n to symbolize that this is the set of numbers 1, 2, 3, 4, 5, 6. So my dot, dot, dot means it keeps going. Okay. And it keeps going forever. And when something gets going forever and ever and ever and has no end, we say it goes to infinity, or this is an infinite set of numbers, because it keeps getting bigger. Okay, well, after you've learned 1, 2, 3, you started to learn about, well, nothing. Well, when you have empty hands, oh, mommy, I ate all my food, I got none left. I'm down to 0. So the 0 comes in 1, 2, 3, keeps going. So 0, when we include that, we're not talking about what are called the whole numbers. And again, we use the W, but then we have an extra slash at the start. Well, and then we get a little bit bigger and we start to learn about what negatives are. So those go from negative infinity, start building up, and to show our pattern, I generally go to -2, -1, it includes 0, and then now we're up into our positives, and it keeps going all the way up to positive infinity. These are integers, and we've been working on integers in class. Integers gets a Z with a slash. Well, there's other numbers in between the integers. So we've got our fractions. So if I make a fraction out of an integer over another integer, then I've made a fraction, and my math word for fraction is a rational. So the rational numbers get a Q with a slash through it. Now these are fractions, so this includes something like the number 10, because I can write it as 10 over 1. When we look at numbers, it also includes numbers like fractions, decimals, so like 0.5, that would be 5 over 10. A decimal like 0.444 that keeps going on forever, so we do the little bar to say it goes on forever, because I can write that as a fraction, that's 4 over 9. We've got more numbers, so what about ones that don't look like this, that don't repeat or don't end? So those would be called our irrational numbers. Oops, I spelled that wrong. IRR, irrational numbers. They get the I as the symbol. And this is a specific set of numbers where the decimals never end and keep changing. Decimals that don't end, and they keep changing. So, everybody's favorite, that's pi. That's also square root of 2. Square root, maybe it's the negative square root of 17. So if you type that into your calculator to double check, you'll get a whole bunch of decimal numbers and none of them repeat. So there's no repeating pattern to it. Those are irrational numbers. All of these, so all of the above, all of these are part of what are called the real numbers. So the real numbers are every number that we're used to. There's other ones. There's imaginary numbers, so the square root of negative numbers, but we don't worry about that in high school right now. So all these are part of the real numbers. So a real number uses that symbol. So the numbers say like on an XY axis. all these numbers in there, every single number you could possibly think of, they're all real numbers. So we often write a set like this. So this would mean that, so my curly Q bracket, set of numbers. So X is my numbers. This funny looking E means is any. Oops. Set of numbers is any. And then I use the symbol to say it's real numbers. Mathematicians like to write in symbols. So we don't use a whole lot of words there. Now we also have a few things called subsets. So a subset is where you list out just some of the numbers. So like a subset of, say, the natural numbers might be 8, 10, and sure, 15. That would be a subset. This could be a subset of natural numbers. 8, 10, and 15. Oh, those also are included in my whole numbers. Oh, these are also integers. So some numbers count under more of these columns here. Oh, rationals. So these can all be written as fractions. They're not irrationals, but they are definitely real numbers. Now I can have a subset of this subset. So I could take out maybe 8 would be a subset of that one. I could take out maybe 8 and 15, and I've created another subset. There is a special subset called the null set. So that one's the empty one. It's empty. It has nothing in it. So it's just a couple of curly brackets. And these basically are the types of numbers that we talk about. So as we talk about the real numbers, so this is a graphic that we've posted, and it shows that the real numbers includes all rationals and irrational numbers. There's an example of some rational numbers. They also include integers, which also includes whole numbers, which also includes some natural numbers. So it just kind of helps to show that each one of these, so the natural numbers are in the whole numbers, are in the integers, are in the rationals. So here we've got a real number is any number that can be found on the number line. Pi is an irrational number. -1/10 is a rational. -2 is a rational and an integer. 0 is a rational number, an integer, and a whole number. And 3 is a rational, an integer, a whole number, and a natural number.